let me introduce what is Eulerian path and Eulerian circuit. So path in a graph is said to be Eulerian path if it covers each edge of the graph exactly once. That means, for example, if I consider, suppose this graph, I am considering, suppose these are the vertex x, y, suppose this is w, this is v, this is u. Suppose these are the edges what you have, suppose e1, e2, e3, e4, e5. Okay, if I consider this graph, okay, so what will be Eulerian path? There can be multiple Eulerian path. Okay, so if I just consider this traveling, suppose this traveling I am considering, this traveling, suppose u to u1, then v, then e2, then w, then e3, then e4, then e3, then x, then e4, then y. Okay, then e5 and come back to w. Okay, so if I consider this path, that is u e1, v e2, w e3, x e4, y e5, w, then here you can observe each of these edges are covered exactly once. So this is one possible Eulerian path. Okay, so similarly you can take another path also. Okay, but make sure you are covering each of these edges exactly once. Okay, similarly, see u e1, v e2, w e5, y e4, x e3, w. This is another Eulerian path. Likewise, you can take different Eulerian path, but after that you cannot go here in this side, because in that case the edge, this particular edge will be covered twice. That is not allowed for Eulerian path. Okay, now what is Eulerian circuit? See, Eulerian circuit. What is Eulerian circuit? So Eulerian circuit. What is Eulerian circuit? See, when you are considering a circuit, means obviously it should be a closed graph. Okay, so the main concept is same. That means each of these edges will be covered exactly once. So in that case, this becomes a Eulerian circuit. So if I write formally, that is, a circuit in a graph is said to be Eulerian if it covers each edge exactly once. A circuit, okay, is said to be Eulerian circuit. Okay, if it covers each of these edges exactly once. Okay, make sure this is a circuit. Okay, circuit means starting and ending vertex, it should be same. So one example I will be considering here. It is a little complicated example, so all of you first draw this. A, A to B, this is A, this is A to B, then C, then here you have D, here you have E, then you have F here, then you have, see this, G here, then you have H here, then you have this direction I, J, K, L, and here this one is also connected. Okay, somehow it looks like this. Now here these are the corresponding edges you also have. Okay, see, ultimately this is your graph. Okay, now suppose I am denoting this one by 1, this is by 2, this edges. Okay, this is 3, this is 4, and this is 5, 6, 7, 8, 9, this is 10, 11, 12, this is 13, likewise suppose this is 14, 15, 16, 17, and here we go 18. Okay, now find out Eulerian circuit. Find out Eulerian circuit from this graph. From this graph, find out Eulerian circuit. See, your target is to find a circuit, first thing, and second thing, each of the edges should be covered exactly once. So let's try this. Okay, suppose we start from here. Suppose we start from here. Okay, so we go this side, we cover this. Okay, suppose let us go here, cover this, then we cover this one, then we cover this, then we cover this, then we cover this, then we cover this, then cover this one, then cover this, then come back here, cover this, now go here, this side, now cover this. So now see, here you are coming back. Okay, here you started from here, so it is not allowed. Okay, got the point? It is from here you cannot go this direction and come back here, it is not allowed. So what you can do, you can skip this direction, you can come back here. See, go this direction, cover this one, this one, this one, this. Okay, but you are coming back here again, without covering this part, and this part. Got the point? So this cannot be a Eulerian circuit, because for Eulerian circuit each of the edges has to be covered. So you are not covering this part, these three edges you are not covering with this choice. Got my point? Okay, now see, so because of this position you have this problem. Okay, now see, suppose you start from here, and you first cover this part. Okay, first cover this part. Let's try this with different color. Suppose you start from here, now you cover this first. Okay, you cover this, now you cover this part, cover this part, cover this one, okay, like this you can cover this. Okay, you can cover this. Okay, and you can come back here. So in this case also you can see all the edges are not covered, so it is not a possible Eulerian circuit. So what you can do, you can start from any other point. Suppose you can start from here, okay, so if you are starting from here, then you cover this. Okay, now you cover this, cover this, Okay, like this you have to try actually. All of this you are covering. Now see, here you can cover this, cover this, this part, this part, this. Okay, now you can see all of this you are covering, and ultimately you can come back here. So in this choice you are covering all of these edges exactly once, exactly once. So in this case you got your Eulerian circuit. So how do you got this Eulerian circuit? See, started from A, then 1, then you had this B, then what you had 2, then C. Likewise you just follow this circuit. Okay, follow this and just give the name. Ultimately what you had the last step 12 and A. Okay, so this is your Eulerian circuit, one Eulerian circuit. So likewise you can have multiple Eulerian circuit. You can try out from this graph itself. Okay, so this is how we got Eulerian circuit. It is little bit complicated if you are getting a graph like this. Okay, anyway you should practice this type of question and finding the Eulerian circuit. Now what is Eulerian graph? What is Eulerian graph? What is Eulerian graph? A graph, a connected graph which contain an Eulerian circuit. A connected, this is the formal definition, a connected graph which contain Eulerian circuit, which contain Eulerian circuit is called Eulerian graph. Okay, so example, you can have this example itself. Okay, so this is Eulerian graph. Suppose you have a graph like this. This one, okay, is it a Eulerian graph? The question is whether this graph is a Eulerian graph or not. Okay, so how do you check that? So your target is to find Eulerian circuit. Obviously it is a connected graph, so just try to find is there any Eulerian circuit present in this graph. So how to find that? See, if you start from here, your target is to cover all the edges exactly once. Suppose here you are going here. Okay, you're going here, 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 and finally come back here. So yes, you got a Eulerian circuit is already present here. That means this is a Eulerian path or Eulerian graph. Okay, so this is how we check a graph is Eulerian or not. Inside that Eulerian circuit should be present.